guys, welcome to Homeline Studying YouTube channel. I am Bainomo Vincent, and today we are going to look at 510-2, that is Physics Paper 2 A-Level, and the topic is Electrostatics. Guys, ensure to subscribe to our YouTube channel for more videos. Now today's topic, we are specifically going to look at electrostatics, and like I told you, electrostatics is simply the study of charges at rest. Remember, in future we shall look at current electricity, looking at the electrons moving. But in here, we are looking at charges that are not moving. That's what makes it to be electrostatics. And remember, charges can either be positive or they can be negative. And a body, so therefore, a body can be charged either positively or negatively. We can have a positively charged body or we can have a negatively charged body. And the body which is not charged, we at times call it uncharged body, or we can at times call it a neutral body. So guys, we are going to look at methods of how we can charge those bodies. How is it possible for us to charge those bodies? One, we are specifically going to look at two methods. The first method is called charging by rubbing. In some other books, they will call it charging by friction. The second method is what we call charging by induction. So we induce a charge on a particular body. So those are two methods that we are going to dwell on so much for us to be in position to see how we can charge different bodies. So guys, I'm going to take you through on how we can charge a body by a process called friction. Guys, when you talk about charging by rubbing, imagine you have two bodies. You have maybe, I'm just going to break down these two pieces of chalk. If you have two bodies, this is body A, body B, and they are different. Maybe probably they're made up of different materials. And I rub them together for some time, heat is generated. And now we are saying that once heat is generated, a material with a lower work function, what do I mean when I say lower work function? In physics paper 2, of course you look at lower work function, work function in physics paper 1. But in paper 2, I am looking at that material whose electrons are loosely bound. So this heat generated is enough to make this material with a lower work function to release or to lose its electrons to the other material with a higher work function. So therefore, when you rub these two different materials together, the material with a lower work function will lose its electrons very fast to the other material with a higher work function. Now, the material which has lost electrons becomes positively charged. The one which has gained electrons becomes negatively charged. That's how we can simply charge bodies by friction. Remember your primary, whereby a teacher will tell you just rub the pen in the hair and then you bring it close to smaller pieces of paper. Do you know what would happen? The smaller pieces of paper would just jump onto the pen. Do you know why? It's because when you rub a pen in your head or in your hair, the pen acquires a charge. And now once it acquires this charge, it attracts the smaller papers. We shall see the law of electrostatics as we proceed. So therefore, that is how basically we can charge a body by rubbing. You get two bodies, once you rub them together, heat is generated. And the heat that is generated is enough to make a material with a lower work function to release electrons to the other material with a higher work function. So the material which has lost electrons becomes what? Positively charged. The other material which has gained becomes negatively charged. Be reminded, students, that the number of electrons which are lost from this material is equal to the number of electrons gained by this material. Okay? So I hope that is clearly understood. That is how we can charge by rubbing. Now, I want to give you some of the examples of charging by rubbing. And they are they are very common, as you're going to see. Okay, guys. So we have finished charging by rubbing. Let us look at some of the examples. Now, when you get an ebonite rod, I will call an ebonite rod a polythene rod, I'll call it a plastic rod. When you rub it with fur, I will call fur maybe hair, call it wool or something of that kind. Now when you rub them together, it will be observed that fur or hair will lose its electrons very fast to ebonite. And remember I told you that the material that loses its electrons fast becomes positively charged. The one that gains electrons becomes negatively charged. So therefore, when you rub an ebonite rod, a polythene rod, a plastic rod with fur or hair, hair will become positively charged or fur will become positively charged, whereas the ebonite rod will become negatively charged because it gains electrons. The second common example is a glass rod rubbed with silk. Silk can be a piece of cloth, okay? Anything made of wool or something of that kind. So when you rub glass rod with silk, glass tends to lose its electrons very fast than silk. So in this case, the glass becomes positively charged because it loses electrons, whereas silk becomes negatively charged. So therefore, members, it is very, very important to know these scenarios and how charging by rubbing is possible. So now we are going to look at how a charged body can attract a neutral body. Remember I told you that a neutral body is that body that has both positive and negative charges. Then a positively charged body is that one which has only positive charges. A negatively charged body is that one which only has negative charges. So therefore we want to see how a charged body can attract a neutral body. Watch. Okay guys, let us look at how a neutral body can be attracted by a charged body. Guys, just imagine. We are saying that when you bring a charged body can be positively charged or it can be negatively charged. Now when you bring it close to a neutral body, and in this case a neutral body is that body which is having both positive and negative charges. Now when it comes close, we are saying that when the uncharged body is brought nearby a charged ebonite rod, that's negatively charged. We are giving an example. You could even say positively charged rod. Charges on the ebonite rod repel the free electrons on the body to the remote end and attracts the positive charges to the nearby end. Therefore, the conductor or the body, actually let me call it the body is now attracted by the ebonite rod. Let me just explain it using just this simple diagram here. Just imagine, this is the uncharged body. Uncharged body has both positive and negative. And you bring it close to a negatively charged rod. This is a negatively charged rod. Now what happens is that when you bring them together, these electrons or these charges will repel similar charges to the far end. So meaning that in our new diagram, you will have positive charges close, then the negative charges shall be repelled far away. So we shall remain with now negative charges here. But these negative charges shall repel the negative charges here to the far end because they are similar charges. And the positive charges shall remain in here. So therefore this will create a strong attraction force. The force of attraction will be stronger than the force of repulsion. And because the force of attraction is stronger than the repulsive force, these two bodies will get attracted or will attract each other. So that's why we are saying that a charged body can get attracted to a charged body. Simple, because these charges will push the electrons or the negative charges to move far away, will remain with positive charges, and this positive charge and negative charge, they create what? An attraction. And once the attraction force is greater than the repulsive force, the bodies will attract. So that's how attraction is possible. But comrades, let us look at the law of electrostatics. Okay guys, let's look at the law of electrostatics. Quite oftenly, we normally confuse law of electrostatics with the law of magnetism. So, law of electrostatics says that like charges repel while unlike charges attract. Remember, the law of magnetism states that like poles repel and unlike poles attract. So similarly, you have to be very careful when you are stating this law. Here we are talking about charges, not poles. I hope I've cleared that. Now, members, let us look at charging by induction. We've looked at charging by rubbing. We said another method is charging by induction. Like I told you, how do you get coronavirus? Get coronavirus when you stand near someone who is coughing, when someone is sneezing, and then you touch your soft parts, you get coronavirus. Similarly, that means you are not supposed to get that virus, but the virus has been induced in you, onto you. So similarly, some bodies are not supposed to be charged. Look at this. This body may be charged, but this one may be uncharged. But the fact that I've brought them close to each other, this one may also end up getting charged. So when this body gets charged as a result of this one, then we shall say that this one has acquired a charge by a process called induction. So similarly, charging a body by induction, you can charge it both positively or negatively. Let us take an example. If you want to charge a metasphere positively, metasphere looks like this. I hope my cameraman can show you. A metasphere looks like this. So suppose you want to charge it positively. Remember, this is an uncharged metasphere, so it has two charges, positive and negative. But we want it to have a positive charge. So what you are going to do, if you want to charge it positively, you will bring a negatively charged rod. This rod should be negative. If you want to charge it positively, you should bring a negatively charged rod. Now, when you bring a negatively charged rod, remember initially, the charges were like this. They are just mixed up. So when you bring a negatively charged rod, then you will have positive charges coming here and negative charges pushed away. Why are they pushed away? Because they cannot be here. By the law of electrostatics, it is very clear that like charges repel each other. So these ones will be repelled far away, then these ones will be induced here. So meaning that now, once you have this statement, I mean, this is exactly what happens when you bring a negative charge close to the uncharged metasphere. Now let us look at what happens next. So what we do, we earth. How do we earth? We earth by touching. Okay? So when you touch, these electrons will flow to the ground. These electrons will flow to the ground. And now once electrons flow to the ground, remember you do all those things when the negatively charged rod is in position. So once electrons flow to the ground, you remain with a charged sphere. This is a negatively charged rod. Now you remain with a sphere with only positive charges. Why? Because the electrons have been taken to the ground. So you will remain with this now. Now what we do, we take away the rod. You remove the rod. Now once you remove the rod, these positive charges here, these positive charges will redistribute themselves on this sphere. And at the end of it all, the sphere will become positively charged. Let's first take a quick break. We shall get back. So now, welcome back, guys. So I was explaining to you how the redistribution of charges take place there. So you can see that the side of the sphere near to the charged rod acquires a positive charge, as you can see. This is the rod. Now the side of the sphere which is near it will acquire a positive charge, and the other side, which is far, this one here, will acquire a negative charge. Now with the charged body still in position, the metasphere is then earthed. So with the charged rod still in position, you touch there. You earth it by touching. So meaning if you touch there, electrons will flow through you to the earth or to the ground. So electrons will flow to the earth, leaving the metasphere with only positive charges. As you can see, it shows that electrons are flowing to the earth. We are leaving the sphere with only positive charges. So members, let us now see what comes in next. Guys, let us finish up this. Now the earthing is then broken. You break the earthing, you remove the hand, okay? Remember you are touching there for electrons to flow. Now you remove the hand. So the charged rod is removed. You remove it now, and the positive charges will distribute themselves all over the sphere, and the sphere will become positively charged. And you finish the story. That's how simple it is. Like I've told you, whenever you're explaining the things, it's like as if you are narrating a story. You've said that, for example, if you want to charge positively, you bring a negatively charged rod. Now when you bring the negatively charged rod, the positive charges will come close, then the negative charges will be pushed far away. So what will happen? You now earth while the charged rod is still in position. Electrons will flow to the ground. You get me? So that means you will leave the charged body, you will leave the sphere with only positive charges. So what happens next? You break the earthing. So when you break the earthing and then you remove the charged rod, the positive charges will distribute themselves all over the sphere, and then the sphere shall be positively charged. You can use the same narrative to explain how you can charge a sphere negatively. This time around, you will bring a positively charged rod. Now when you bring a positively charged rod, that means that negative charges shall be induced on the side near the positively charged rod, whereas the positive charges shall be pushed far away. So you earth. Now this time around, when you earth, electrons will flow from the ground. They will not flow to, but rather flow from the ground. So once they flow from the ground, they will neutralize the positive charges on that conductor. Positive charges will not move, but rather electrons will flow from the ground and they come and neutralize the what? The positive charges. So now what happens? After neutralizing the positive charges, the sphere shall remain with only negative charges. So you break the earthing, and then you also take away the positively charged rod. Now the negative charges shall distribute themselves on the surface, on the surface of the conductor. At the end of it all, the whole sphere shall be negatively charged. So guys, that's how